All right. Can everyone hear me? Perfect. Welcome to United Astronomy Clubs of New Jersey, here in Hope, New Jersey, located at Jenny Jump State Park. So while I see a few people wandering down, and so we give them time to settle, I want to welcome you all, both not only people who have joined us here on site, but also who are joining us in our online chat room, because that is right, we do live stream these presentations when we have them. So if you're ever sitting at home and wondering what to do on a Saturday night and you're bored, or if you just really love science, you should come check us out. We live stream these on YouTube and Twitch. Plus, any past streams we've done, we also keep those archived on YouTube. So if you look on our website, uacnj.org, and you see a talk, man, I really wish I had seen last week's talk with Jamie Rodriguez about his astrophotography. You can go back and watch that at your own leisure.
The talk was inspired.
And you can also ask questions there in the comments. And when I see them, I do try and get those answered for you. Oh, good. That finally decided to kick in. What? Sometimes the speaker back there doesn't work. Like I said, if you check out our website, uacnj.org, you'll find a list of not only our upcoming talks, but also all of our member clubs, because we are a club made up of other clubs. We do try and connect you to your local club, because the easiest way to get into astronomy is to have it accessible to you. With that in mind, you can also check us out on our social media pages, our Facebook, our Instagram. We have a Discord server where you can share all your lovely astrophotography, or share pictures of your astronomy rig, your telescope, and whatnot, or get any questions answered there as well. So, now that it looks like people have mostly settled, for the people here, I get to run you through a safety briefing. If you need to use the bathroom, that is the porta potty in the back, to my left, your right. We also have a little museum and gift shop area outlined in red here. I'll be manning that after the talk, because, again, they still have not given me the ability to be in two places at once. And unfortunately, 10 years of retail also has not given me that ability yet. I'm still trying. But I will be manning that afterwards. When we go to leave here, chances are it will be dark. We are using our headlights when we leave, because we do not want to be run over. We do not want to see anyone get run over. There's just too much paperwork if people get run over. That being said, if we are using our flashlights to get around, do keep those pointed at the ground, because let's face it, it's all annoying when someone's having a rave with their flashlight and suddenly you have no night vision. All right, so tonight's talk is So You Want to Buy a Telescope with Dan Kirby. Dan has a bachelor's degree in physics with a minor in history and a master's degree in computer science. He's been an amateur astronomer since childhood and a member of the board of the Amateur Astronomers Association of New York and
As well as the board.
Yeah, the phrasing you did there was weird. Like, that's not English. And and also helps on the board of United Astronomy Clubs of New Jersey. He is the site coordinator for AAA's, his home club's activity here at Jenny Jump Observatory. He spent many lonely nights here, also nights with friends. Don't even lie about that.
Those two.
Oh, and while astronomy is by far Daniel's most passionate hobby, he also enjoys reading, both fiction and nonfiction, cycling, camping, and riding self-balancing personal electric vehicles. For his day job, he's a software engineer, and you can follow his astronomy Instagram, which I'm sure he will shamelessly plug at some point in the night.
You'll never guess what slide it's on.
The first one, probably.
No. I should put it there. Yeah. So as was introduced, the title of tonight's talk is So You Want to Buy a Telescope. I'm Daniel Kirby from Amateur Astronomers Association of New York and the United Astronomy Clubs of New Jersey. So a little bit about me. As was mentioned, I'm a lifelong, though no longer teenage, astronomy hobbyist. I have degrees in physics and computer science. My trade is software engineering, And I started getting back into astronomy, during the pandemic. We actually took a trip out up to upstate New York, and we stayed in an Airbnb, when everyone was vacationing by staying inside. And I saw the Milky Way, and I was like, oh man, I gotta go get another telescope like this one that I is in this news article about me from what is that, 2006? Yeah. So yeah, a little bit about you, the audience. So the intended audience of this talk is someone who's interested in astronomy, but maybe you don't know much other than that you want to get your own scope, and you're making the right decision. This is a really fun hobby. You can meet some really cool people and enjoy some beautiful nights out under the stars, and it will change the way you look at the cosmos. So a bit about this talk. I'm going to go through some basics about astronomy, some basics about telescopes. We're going to go through each of the major types of telescopes that you'll find on the market, and I will go through a list of product recommendations for various types of consumers, and then some accessories, miscellanea, expectations, and some additional tips. Loading. Is the Wi-Fi not working? Oh, here it goes.
Here's your first problem. We tell you not to rely on the Wi-Fi.
I mean, I have a copy of the talk. Okay. So the celestial sphere. Because of the rotation of the Earth, the stars appear to rotate around the sky about once per day. Imagine you're standing outside on a clear night as the sun sets. You see a bright star dead on the eastern horizon. If you come out the next night, that star will be a little higher in the sky at sunset, rising about 4 minutes earlier. This happens because the Earth is revolving around the sun. So from our perspective, it appears that the sun has moved about 1 degree every day, right? 365 degrees in a circle, or 360 degrees in a circle, 365 days in a year. From the northern hemisphere, our North Star Polaris appears to be at the top of this celestial sphere. Stars that lie closer to Polaris than the horizon are called circumpolar and are visible all year round. So this is a star trail image I took in December during the Perseid meteor shower. I'm not gonna pixel peep and find this because the point of this is not to show my astrophotography work, but there are a couple of Perseids that are visible in this image. And it's also on my Instagram, which is at the Intergalactic Wanderer. So this is a 12-hour star trail. You can see that based on the fact that the circles go about halfway around, which is what they are because it's 12 hours. And you also will notice that Polaris actually moves a little bit. Polaris is not actually exactly on the North Pole. It's a little bit out, but it's not far enough that you would notice with the naked eye. At the equator, Polaris is permanently on the northern horizon. All the stars appear to travel in a straight line across the sky. And in the southern hemisphere, we see the stars rotate around the opposite point. People often say that we don't have a south star. We actually do. It's called Sigma Octantis, but it's much dimmer than Polaris. It's not widely known. It's not really easy to pick out by eye. Astrophotographers in the southern hemisphere, they have all sorts of tricks to find the south celestial pole just by like the bright stars that are around here in octans. So unlike the fixed stars, the 6 if you count Uranus, naked eye planets wander relative to the background. So the word planet actually means wanderer in Greek. That's where that term comes from. And this wandering follows a regular pattern, however, because the solar system, unlike the Earth, is not flat, or is flat. It's basically flat. The planets all travel around a path called the ecliptic, and the sun also follows this path. So if you look at the solar system from the side, you kind of have this like flat pancake. So in our sky, the planets are always like on this one line. The ancient Greeks considered the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn to be planets. They didn't notice Uranus. Uranus is just barely on the edge of visibility. If you have really good eyes in a really dark sky, you might be able to pick out Uranus if you know where it is. And actually, even though Uranus was discovered with a telescope, we have been able to go back and find like what we call pre-covery evidence of people who had seen Uranus documented its location, thought it was a star, and then later star maps is just not there because it had moved, and people just were like, oh, I guess maybe that star disappeared or whatever, right? So you can see the sun moves across the ecliptic. Now you might be thinking like, wait a minute, but like I can't see the stars during the day. So how do we know what constellation the sun is in? And this was my first thought about this, right? Well, so the way you do this is right before sunset, or right after sunset, or right before sunrise. You notice what stars are near the horizon, and that's how you can track, what constellation the sun's in. So over the course of the year, the sun passes through 13 constellations. Those are the 13 constellations of the zodiac. The 12 that are associated with the 12 zodiac signs, and Ophiuchus, because they wanted 12 zodiac signs in 12 months, so Ophiuchus got the boot. You'll also notice that on this diagram that the astronomical zodiac has shifted because of the precession of the Earth, and it no longer aligns with the astrological zodiac. So I'm a Capricorn, according to astrology, but if you actually look at my birthday, the sun's in Sagittarius. This is one of the reasons that astronomers tend not to put a lot of stock in astrology. And this is just another diagram to sort of show you from the sun-centered perspective, because obviously we're kind of describing things as though the Earth is the center of the universe, which it is not. So from the sun, we're seeing all these constellations that, from our perspective, appear to be behind it. Ooh, that jumped. Sorry. Let's see if this started working. Okay, so our mantra for tonight is going to be the best telescope is the one that gets used. Say it with me now. The best telescope is the one that gets used. Yes. So I'm going to start with a question, which, and the spoilers. Why do we use telescopes to look at the night sky? That's actually pretty close to the right answer. Anybody else? Why do we use telescopes to look at the night sky? You never thought about this before, huh? It's a novel question. Okay, so a lot of people think that we use telescopes for magnification. And it is indeed a property of telescopes. They magnify the image that you're looking at. However, it actually turns out that a lot of things in the sky are quite big from a visual perspective. So this is a photograph that cannot be taken for a couple of reasons. So that's the moon, and that's the Andromeda galaxy to scale. So the first reason you can't take this photograph is that the moon is actually never this close to Andromeda in the sky. Andromeda is pretty far from the ecliptic, and the moon kind of stays around the ecliptic. The other reason is that there's no exposure setting that will allow you to take a picture of something as bright as the moon and something as dim as Andromeda in the background, right? But this is meant to illustrate that, you think of the moon as being pretty big, right? You don't need a ton of magnification to look at the moon, and yet Andromeda is like 5 moons across. And especially when you take into account, the extra bits of it, right? So we actually use telescopes mostly to gather more light than our eyes are able to. Our pupils are only a few millimeters wide, but telescopes' objective can be much, much bigger, and we're going to cover that. So we're going to start out with a few top-line numbers that you should be looking at when you're looking at buying a telescope. If you were buying a car, what would you want to know? What is the first thing you want to know about it? Price, that's a good one. Gas, yeah, fuel economy. I seeded the pot by having the fuel economy sticker here, and like maybe I don't know, 0 to 60. That's something people care about. I care about that. Range, maybe. You probably are interested in how far you can drive the thing. So for telescopes, I picked out 3 specs that I want you to focus on that are helpful: the aperture, the focal length, and the limiting magnitude. So I'm going to go through each one of those, and we're going to start with the aperture. So if you learn nothing else from this talk other than the best telescope is the one that gets used, it should be that the most important number about a telescope is its aperture. So aperture is the width of the lens for a refractor, or the width of the mirror for a reflector. It's basically the amount of light that's coming in based on the diameter of whatever circle it's going through. More aperture means more light. Typically, consumer, beginner grade telescopes are going to be somewhere between about 2 inches to 8 inches in aperture. Focal length is the distance the optical train travels within the telescope before it reaches the focal point, which is where your eye is. Longer focal lengths will lend themselves to more magnification, which will help you view smaller objects. And of course, I mean smaller in the visual sense, right? Like Andromeda is much, 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 much bigger than the moon in physical terms, but because it's farther away, it's only about 5 times bigger than the moon in the visual sense. So magnification is based on the ratio between the telescope focal length and the eyepiece focal length. So a 2,000 millimeter telescope with a 20 millimeter eyepiece will be 100x power, probably about the high end of the amount of power that you want for most visual astronomy. And typical consumer beginner telescopes are going to be somewhere between 400 and 2,000 millimeters in focal length. Don't ask me why we do focal length in millimeters and we do aperture in inches. I don't know. In Europe, they do them both in millimeters. Some smaller refractors, they do the aperture in millimeters, but for whatever reason, we mix the two. And then finally, limiting magnitude. So magnitude is a logarithmic scale that measures the brightness of objects in the sky, objects in general. So we got this from the ancient Greeks, and basically their idea was they were going to have 6 classes of stars, and stars of the first class would be the brightest ones, down to the dimmest ones, which would be 6 magnitudes. So we kind of bolted a real logarithmic scale onto this kind of ad hoc ancient system. So the brightest stars are around magnitude 1, but actually there's a couple that are a little bit brighter, so we have to go into the negatives. So Sirius is a little bit in the negative. Polaris is pretty close to 1 and change. I think it's like 2-ish. And so basically limiting magnitude is a measure of the dimmest stars or objects the telescope can be used to observe. One jump in magnitude is about 2.5 times dimmer. Remember I said it was a logarithmic scale. And you can look at catalogs of deep sky objects and compare that to the advertised magnitude of your telescope, but you must be wary of light pollution. So just as your car manufacturer is going to tell you the miles per gallon in ideal laboratory conditions, your telescope manufacturer is going to tell you what the limiting magnitude is in the darkest skies imaginable with zero humidity, in no moon, the perfect situation. I would usually say that if you have a telescope with a limiting magnitude like 12 to 14, which is typical for consumer grade telescopes, around here chop that down to like 9. Chop like 3 to 4 digits of magnitude. And this diagram shows a bunch of objects based on their magnitude, and then the limiting magnitude, the Hubble Space Telescope, which is a little bit less than 30. So now we're going to go through the major types of telescopes that are available to consumers. There are other types of telescopes out there. I have encountered them in the wild. These are the ones you can actually buy at the store, and the ones you really need to know about. There are refractors, and catadioptrics, or CATs. So refractors, we're going to start with these because this is what you're thinking of when I say telescope. This is the pirate spyglass kind of telescope. It's got a lens at one end. It's got another lens at the back. And there's 2 types of these. There's achromats and apochromats. I'm going to explain that on the next slide. These are pretty easy to use. They generally don't require any maintenance. A nice advantage of lens optics is they tend to offer a little bit more contrast, so they can be good for picking out nebulas. We call that refractor magic. And they're pretty good for stellar observations and splitting double stars, but as you get to like dimmer deep sky objects, they kind of are a little limited. A disadvantage here, the price you're going to pay per aperture is very high with a refractor. And as you get to a larger aperture, these things are going to get heavy. It's hard to make really big pieces of glass, and they are vulnerable to accumulation of dew on the lens, and they experience chromatic aberration, which I'm going to go over on the next slide when we talk about achromats and apochromats. So if you've ever seen that one Pink Floyd album, that when light goes, or if you made the most of your middle school science class, that when light goes through glass, you split off into the colors of the rainbow. Nice, beautiful, very pretty, but that's not what we want, right? We want all the colors of light to come together at one point where your eye is located. And so an achromat adds a second piece of optical element, piece of glass, that will rejoin most wavelengths of light. They tend not to be able to get the green to be at the same focal point. So when you look through an achromat, which most of the cheaper refractors will be, you're gonna see the stars are a little purplish. Some people notice this more than others. We say that when somebody can see this, they have expensive eyes because apochromats are always more expensive. Apochromats, I generally would not recommend for a beginner, but they add a third optical element to rejoin the green. These are really popular for photography since it makes it so there's less work you have to do to get the colors right afterwards. So I'm going to talk about reflectors. So the Newtonian reflector is one of the most versatile telescope designs ever. So Isaac Newton actually designed this. And it was a reaction to how hard it was to build big refractors, because with a mirror, you only have to polish one side, and you can make a much bigger objective that's cheap and easy to move around. So definitely the most popular amateur telescope design. Generally, Newtonian reflectors are the overall class, but we have a term for ones that are mounted a certain way, which is a Dobsonian. So these two are the same type of telescope, but this one is on what we call an equatorial mount, and this one's on a Dobsonian mount. So Dobsonian just means it kind of moves basically like a cannon. So you have like this up and down, left and right. So Dobsonians are very popular because you don't have to spend a lot of money on a mount. You got this big telescope, and it just sort of goes on this kind of like lazy Susan thing that like you move it around. Really good aperture for unit cost. You're less likely to get dewed up because the mirror is inside the telescope instead of like right on the front with the lens. And with a Dobsonian, you don't have to spend a lot of money on a mount. Mirrors don't experience chromatic aberration at all. That's not a thing that happens to them. You will get less contrast than a refractor. You might have to clean the mirror, but obviously you have to clean a lens. And you need to collimate them. I'll explain that in the next slide. And this is really hard to use for terrestrial targets. So there's a few reasons for that. But basically, so first of all, this Dobsonian design, this is very heavily designed for looking at the night sky, right? Because you're on the ground, basically. And, you want to look at something on the horizon, you're pretty low. But the other problem is that telescopes actually flip the image. So everything you see is going to be flipped up and down, left and right. Astronomers, we don't care about that because there's no up and down in space. There's no wrong way to look at space. If you're using this like on a hike because you want to like do some bird watching, it's going to look kind of funny. And to get an erect image, eyepiece into a Dobsonian, like it's hard. It's hard to make that work properly. So it's a downside of a reflector is you're never going to use it for sightseeing on the ground. So collimation, sometimes part of your optical train is going to be misaligned. It causes suboptimal views. Things just look sort of fuzzy. This happens to reflectors after they've been jostled around too much. Maybe you put them in your car and you drive them up to the observatory. There's going to be a set of screws on the back that you can tighten and loosen to correct the collimation, both on the primary and secondary mirror. And if you just bought a telescope, you really don't need to do this. Don't mess around with this until you've taken it on a few rocky road trips. There's a lot of ways to do it. This is a diagram for how to do it by eyeball. I do it with a laser. I find that's the most fun or the easiest because I can do that in daylight. I don't waste any of my observing time. But you can do it using a star. You can do it using an artificial star, which is called a Cheshire eyepiece. So you basically just create a target to look at, and then you correct it. But if you get a reflector, eventually you're going to wind up having to collimate. And finally, I'm going to talk about catadioptric compound or Cassegrain telescopes. We're going to call them CATs because that's the easiest to say. And then we have CATs and Dobs. So this is sort of a combination of a refractor and a reflector, and it kind of has some of the advantages and disadvantages of both. So a CAT is going to have a lens on the front, which we call a corrector plate. And it's going to have a mirror at the back, and then it's going to have a secondary mirror at the front, and then it's going to send the light out through the back. So why are we doing this? Why are we is the optical trains going through here not once, not twice, but thrice? Well, this basically allows us to have a really long optical train, really long focal length in a smaller, stubbier package. It also, the reason we're using both a mirror and a lens is that the corrector plate and the mirror they basically work together to correct each other's spherical aberrations. That's kind of like stuff around the outside might look a little fuzzy. So we can have a faster mirror, but use the corrector to correct the image. So they have a compact size, and that allowed them to incorporate a lot of electronic gizmos and computer control. These are some of the first telescopes that you could buy with from the factory with computer control and motors, and they're kind of good all-rounder scopes because you got that long focal length, so you can basically use them to look at anything. Some disadvantages, they are costlier than a reflector of comparable aperture, and they kind of have this effect of jack of all trades, master of none, right? And that complex optical terrain makes it a little more difficult to collimate than a Newtonian. There's more than one ways to collimate a cat. I have found the most effective way for me to collimate my cats is using a star, which is really tough because it's like anytime I spend out there under the stars collimating is time I'm not spending actually looking at deep sky objects and enjoying my night. So that's one thing I don't like about them. So basically, just to recap, refractors are more expensive, they're less compact, they have chromatic aberration, and they don't collect as much light. But with a reflector, because it uses a mirror, you will not be able to see any space vampires. So you want to think about that. So I'm just going to talk really quick about mounting. So there's Altaz mounts and there's equatorial mounts. So generally, as a beginner, I think you should be getting an Altaz mount. So as I said earlier, that's kind of like a cannon. It goes left and right, goes up and down. Equatorial mounts basically align one of these two axes with the polar axis of the Earth. So this allows you to turn one to track an object through the sky, basically counter-rotating for the Earth. So why would you want to do that? Well, it lets you keep an object in the telescope for an extended period of time. And the main reason that you might want to do that is because you're photographing it. So if you're not doing astrophotography, I really don't think there's a lot of advantages to an equatorial. It might be nice for outreach. You want to you're showing a bunch of people the same object, but you can get stuff back in quite easily with an Altaz. Okay, so which telescope should I choose for my first? So we're going to go through some specific product recommendations here. So most of these scopes I have listed have similar alternatives from other manufacturers. I'm not getting paid anything for this. I'm a customer just like you. And this is my second year doing this talk, and I price checked all these telescopes this week. Surprisingly, actually, none of them went up in price relative to 2023. One went down, and a few are available for a little bit less on sale. So that's your price, your check-in on inflation. The prices went up a bit from 2022 to 2023, but it seems like they're holding steady now. So the one I'm going to start with is the Orion Short Tube 80. So you can get this for $180 with no mount, and it's an 80 millimeter, which is about pi-inch aperture refractor. Is a 400 millimeter focal length and a limiting magnitude of 12.2. This is a classic beginner refractor. I had one of these when I was a kid. You can get them in the 80A or 80T variants for astronomical and terrestrial viewing. The only difference here is that the terrestrial variant comes with an erect image prism. Remember I said earlier you need special equipment to get the image to be the right way up. But you can switch that out if you have the other one. And the reason we don't use a erect image prism when we're observing deep sky, for the most part, is we don't want to lose any light, and a prism is going to take away a little bit of the light. And you can use this with on a camera tripod, but you probably want a Vixen-compatible telescope mount for it. You can easily find this cheaper for used or even basically new with some accessories thrown in if it's on sale or if you find from another beginner. This is a really good first telescope for a child, and it's totally appropriate for an adult as well. Also, 400 millimeters is a nice low focal length. With this, you see that this one I've shown here has a finder scope on it, so you can use it to sort of find your target. But at 400 millimeters, the telescope is basically its own finder. You're given a really wide field view. This next one is the one that I generally tend to push people towards, especially for children, though it's totally appropriate for adults as well. It's the Orion Star Blast 4.5. So it's a 4.5 inch tabletop Dobsonian. It's a 450 millimeter focal length, so about the same, but its limiting magnitude is 12.9, which is noticeably dimmer. This was the one that went down in price last year. I think it was 270. Now it's down to about 250. And it's the tabletop design is really nice because you can basically plop it on anything. You can put it on a picnic table. You can put it on the hood of your car. And it's enough aperture to do some deep sky objects. And it will come with a Vixen plate. This one I'm showing in this picture here doesn't have a Vixen plate, but the newer ones do. So you can basically put it on almost any mount you're going to buy later on. And this one I really like because it's actually a fast reflector. So you could use this for astrophotography. I do a lot of my astrophotography with a 6-inch. And this is a 4.5, so it's not that much smaller. And then the next one, which I think is probably the one that I'm mostly going to steer more interested people and adults towards, is the Apertura DT6 or DT8 Dobsonian. So this is a favorite. People love these 6 and 8-inch Dobs. I've got a 6-inch Dob, and my buddy Mike in the back there has got an 8-inch Dob. Yeah. So you can get the 6-inch for $420, and you get the 8-inch for $550, and they usually come with a bunch of extras. 1200 millimeter focal length, limiting magnitude 13.4 or 14. Easily could become your favorite telescope. Usable by an adult of any height, but it might get a little bit too tall for a child when looking straight up. So why am I switching from Orion to Apertura here? I previously had recommended Orion. I happened to just look around and see which ones have the sort of best build quality for the price they're offering. Apertura seems to be offering a little bit of a better one right now. If you pick up the Orion, it's going to be fine. There's also one from Celestron. They're all basically the same. They're probably made in the same factory. The real question is just, how is it appointed? What kind of materials are you getting? Because the mirror is probably from the same place, but they might put other stuff on it. Another thing I will mention for the DT8 specifically, and this is why it's in here, is that it comes with a focuser that can accommodate a 2-inch eyepiece. So as you upgrade, you might want to get a 2-inch barrel eyepiece. Those are really fancy, and they're higher end. They give you a wider view, and that's something I think if you're getting an 8-inch Dob, you're probably going to eventually want to run a 2-inch eyepiece on it. Don't supersize to the 10-inch. I'm already kind of supersizing you a little bit by recommending the 8. As these things get bigger, they kind of get heavy, and the 8-inch is a little bit less likely to fit in the backseat of your car. The 6-inch will definitely fit in the backseat of your car. As I said, there's many other options from other manufacturers. They're basically the same. I've never seen a bad one. I chose Apertura this year because it happens to be the best value at MSRP right now. And the 2-inch eyepiece, it depends which one you want. Those are expensive upgrades that beginners should not be looking at, but it's something I want to future-proof you on. There are some affordable ones from Celestron. I have one of those, but the expensive ones can be more expensive than the telescope itself. So I want to just add an honorable mention here to the Explorer Scientific First Light. So it's optically equivalent to the Apertura, but has a bit more of a premium build quality. This is a steep MSRP here, but if you see it on sale, it was apparently they were giving them away for $600 until they sold out. But I'd say that's a really good value. This is the only commercial Dob I've ever seen that follows what's called the mirror diameter rule. So you notice the altitude bearings, that's the like half moons on the side that make it go up and down, are as big or bigger than the mirror. For like high-end Dobs, you want that to be bigger than the mirror, because that's how you get a nice steady motion. This is the only commercial Dob I've ever seen that follows that rule. Okay, so now I'm going to talk about Celestron's SCTs, which are Schmidt Cassegrains. So Schmidt Cassegrain means that the corrector plate is a Schmidt corrector plate. There's other variants, but this is basically the signature product from Celestron. They've been making these since 1970, which is basically almost as long as Ford's been continuously manufacturing the Mustang. And as you can see from this advert from about that time period, they're endorsed by Mr. Spock, so you can use them to explore strange new worlds. These tend to be on the pricier side for a beginner, so I wouldn't buy one I bought one recently, but I would not recommend you buy one of these for your first telescope, but I'm including them so you get an idea what's out there. So the Nexstar SE line is what they're most known for, those orange tubes. These are available in a 4-inch, 5-inch, 6-inch, and 8-inch aperture. They are motorized with computer control go-to, so you need electricity to move them. They will take AA batteries, and they will chew through them extremely fast. If you're running this off of AA's, expect to throw those AA's out after about 4 hours, maybe more like 3. But you can buy a battery for them. The go-to functionality requires the time and date, your GPS coordinates, and at least one, preferably 2 or 3 objects in the sky. You can typically get the object in the eyepiece, but it might not be centered. Of these, I recommend the 6-inch. It retails for $1,099 without any batteries. It's currently on sale, I think, for more like, I think it's about $200 off from Celestron directly. It has a 1,500 millimeter focal length and a limiting magnitude of 13.4. You will notice that's the same limiting magnitude as the 6-inch Dob. The Nexstar Evolution line is their next step up. They're optically equivalent to the equivalent Nexstar SEs, but they come in a 6-inch, an 8-inch, and a 9.25. So you have to get one of these. If you want a 9.25, you have to get one of these. And the mount can be operated manually if the battery dies. You see there's that orange circle on the side. That's what we call a clutch. So you release that, and you can just move it around. If you want to slew around the sky at 2,000 millimeters. So I recommend the 8. I have the 8. It retails for $21.99. I think that's also on sale for about $200 off right now. Limiting magnitude is 14. You'll notice that's the same as the 8-inch Dob. I've not been terribly happy with the mount, and I've had that scope for about 2 years now, and the altitude motor has failed, and I just haven't gotten around to fixing it. I know if you're in an astronomy club, there is somebody, we call him a scope wizard, who will be able to fix whatever happens to your telescope. I haven't brought mine to my club scope wizard yet, but I'm sure he can fix it if he needs to. Also, another thing, this has an internal battery, which there's a trade-off there. With the SE, you have a bunch of options. You can plug it into the wall. You can use your car battery. You can get a camping battery like a Jackery or EcoFlow. But with this, you're lugging around this battery whether you like it or not. On the flip side, that's kind of nice because you can't forget your battery. it's in there. Another issue is that battery fails, you have to break it apart to replace it. But the scope is a high quality scope, and that's going to outlive the mount and any batteries and anything else. Telescopes live long life. So another product I'm going to mention here from Celestron is their StarSense Explorer line. So basically what this does is it uses a flat mirror that is aligned with the optical axis of the telescope to allow your smartphone to do what we call plate solving. So you know how facial recognition works, right? Like you feed a computer an image and it kind of identifies what it's looking at. So basically what you're doing here is your phone is looking at what the telescope's looking at. It's telling you, what part of the sky it's in, and it gives you push-to behavior. So it's like go-to, but there's no motors. You're the motor. You push it around and it tells you, go left, go right, go up, go down, right? And so I would argue that plate solving is actually a little bit more convenient than the computerized go-to systems I've just explained. Because, this telescope, this is going to happen to you. It's going to be 2 a.m. And you realize, oh, crud, I wanted to look at that nebula, but it's behind that tree over there. And with this, you can just pick this thing up, you can move it across the field, and it'll know exactly what it's looking at, right away. Some downsides to this system, you're going to be looking at your phone's screen a lot while you're stargazing. That's going to harm your night vision. You're definitely going to want a power bank because that app is going to drain your phone's battery like nobody's business. And I've just noticed that the build quality on these is a little bit lower than the equivalent non-StarSense telescopes. They have them as Dobsonians. They have other options. I included the Dobsonian in the talk just because I know people, like I'm pushing people toward Dobsonians generally. And it retails for $799.99, which you'll notice is a little bit pricier than the regular vanilla Dobsonian. So you're paying a premium for that bracket, the mirror, and the download code for the app. So can we repeat our mantra? The best telescope is the one that gets used. So think about all the telescopes I've shown you and think about which one you're going to use. Okay, so now you might be thinking, all right, what other accessories should I go out and buy? What else do I need to get started? So I'm going to tell you to buy a field guide. These are two of my favorites, Turn Left at Orion and the Year-Round Messier Marathon Field Guide. So I'm going to talk a little bit about what you're getting with these books. I know we're sort of accustomed to saying, like, I'm just going to go on YouTube, I'm going to watch a video, somebody's going to explain how to do this. You can do that to a certain degree with astronomy, but I think it's still a hobby where you really benefit from having the printed word and having some more time to go through the material than the time you're spending with me. So both of these books give you kind of like an intro, how to use a telescope, the basics of astronomy, and then the second half of the book is going to be a mission. It's going to be, objects you can go look at with your telescope. So I think that's a really good bang for your buck. Honorable mention here is the book Night Watch by Terrence Dickinson. I think this is a good astronomy book generally, but it's kind of a little bit too much, and it's kind of like drinking from a fire hose. So I would not suggest to get it as your first field guide. And you'll probably want a planisphere, which is this little thing at the bottom right here. So it's like this kind of two pieces of cardboard or plastic or whatever, and you spin it around to whatever time and date it is, and it shows you what's going to be visible at the sky, in the sky for your latitude. You usually set to about 40 degrees north, which is most of the major population centers in North America. You could use an app on your phone for this, but I think it's a lot more fun to use a planisphere. By the way, I'm pretty sure we have some in the gift shop. Yeah, we have some in the gift shop. You're probably going to want a red flashlight. So red happens to be the wavelength of light that is least disruptive to night vision, so you can use that to see your gear at night. You're probably going to want a Telrad. I'm going to explain that in a future slide. And you will want to get a membership to your local astronomy club. So this is what it looks like to look through a Telrad. So it's what we call a Power 1 finder. So it does zero magnification. This is a really great way to aim your telescope. As you can see, you just get the sort of bullseye. If you ever played Call of Duty, or like seen a reflex sight, this is how they work. My wife, who knows nothing about telescopes, never done astronomy, I handed her my scope with a Telrad on it. She got Jupiter in the eyepiece, like bim bam boom. So what are some things not to buy? Some things that you maybe don't want to bother with. I would not recommend buying extra eyepieces for a brand new telescope for a beginner. The eyepieces that came with the scope should be fine, and they came with it for a reason. If you want to, upgrade, give yourself some time to figure out what it is that you want to upgrade to. Generally speaking, you're going to find that if you're upgrading, you're buying the same size eyepiece, like the same focal length, and just a more expensive eyepiece that's, it's got argon purging or whatever to give you a better view. Because like the focal length's right, and maybe you just want a higher quality eyepiece to replace the one that came with it. Filters, I don't think you really need any filters for visual astronomy. Maybe a moon filter if you want to look at the moon during full moons. Any astrophotography equipment at all. So astronomy's hard, photography's also hard. You put them together and you have an even harder hobby. If you're excited about astrophotography, Jimmy Rodriguez, good friend of mine, did a talk about this last week, which is up on our YouTube channel. Software, there are great free options. You don't need to pay for any software for astronomy as a beginner. And a collimation tool. Your telescope's factory collimation's fine. You don't need to mess with this until you've been on a few rocky road trips with that thing. Okay, so what about the maybe pile? I'm addicted to shopping and I have so much money. So maybe you might want to buy. Am I still on? Kim? Testing 1 2. I'm seeing the lights. I'm not hearing the speaker. Okay. Okay. Yeah. That's not a challenge for me. So maybe buy a case for your telescope. Maybe a case for your eyepieces, other accessories. You might want a map or a field guide for the moon. And you might want some more detailed star charts for planning ahead of time. So you can get, paper charts that have down to very dim stars, and that way you can spend some prep time like finding what you want to look at. A green laser pointer, people love those. I bring that up here, and I'm like, oh, check this out. And people are like, whoa, look at that laser pointer. And I'm like, wait, but like focus on the thing in the sky I'm showing you. and a Telrad specific finder chart like this. So I showed you before how with a Telrad it's dead easy to get a visible object into the scope. With these finder charts, what you can basically do is say, okay, I want to put that star on that ring, and boom, my target's gonna be in the eyepiece. And by the way, this chart is for M13. This is a really big globular cluster. You could see it tonight, although I think it's gonna be too cloudy. These are literally foolproof. Okay, so you might be thinking, wait a minute, what am I looking with this thing? We talked about all these different telescopes and how they're built and like what the differences are. So what are you going to look at through your telescope, right? Like, what's the whole point of this? So like I said earlier, you might look at terrestrial targets, especially if you have a telescope as well appointed for that. The moon and the planets. You might want to look at double and binary stars. You can split a binary star and see each of the two constituent stars. But I think the thing that keeps people in the hobby, the thing that people are most excited about, is deep sky objects. We're talking about galaxies, nebulas, star clusters, globular clusters, and open clusters. We don't have time to get into that, the difference, but that there are two kinds, and much more. Many of which you can see tonight from our telescopes here, except for the clouds. So this is a map of the sky showing the Messier objects. So the Messier objects are the objects in the Messier catalog. I don't have time to get into what it is, but it's basically one of the first catalogs you're going to use for beginner deep sky objects. So the yellow dots are star clusters, the green dots are nebulas, and the red dots are galaxies. So you see this like U-shaped thing here, that's the Milky Way. That's the plane of our own galaxy, which encircles us all the way around. And you'll notice that there's a bunch of yellow dots that are in the plane, right? Because that's the star clusters of our own galaxy. And then out of the plane, you see this big cluster of galaxies. That's the Virgo cluster in the middle right there. So that's actually what's coming up right now. We call the springtime galaxy season in this hobby because there's all these galaxies in the Virgo cluster. And so every telescope I've shown tonight can see probably every object in this catalog. I'm going to take a bit of a mulligan on that because there's a couple of them that are really dim. And, I mean, you probably have to be in a really dark sky to get all of them. But, so that's 100 objects right there, a little bit more than 100. There's probably like 10,000 objects you can see with an 8-inch telescope. And now I'm going to talk a little bit about expectations. So this is the Andromeda Galaxy. We saw it before. This is a picture I took, by the way, with a telephoto from here. And this thing on the right, this is actually a sketch. So people used to do this. Some people still do this. People look through the eyepiece and sketch what they see. And this is kind of what it's going to look like through the eyepiece. It's going to be this little fuzzball. Maybe you see a secondary fuzzball, which is that satellite galaxy on the left there in my photograph. So you might be thinking, like, why are we spending this money and getting out in the wilderness to sit under the stars and look through the eyepiece when the pictures are much more impressive, right? And why are the pictures more impressive? You might be thinking, well, pictures are more impressive because this is like 3 hours of photographic data, and that's what you can see just with your eye. And I think when I question why we put so much work into looking at these objects visually, I come back to this quote from Star Trek. This is the one. I don't remember, this is one of the good ones, one of the not good ones. But there's a scene where Captain Kirk is climbing up this mountain, and Spock comes up behind him, obviously on a jetpack, and he's like, Captain, it's illogical. You're not going to be able to summit this mountain in a record time. Why would you do this? And Kirk, of course, says the reason you climb a mountain is because it's there. There's something just visceral about the experience of looking through the telescope and seeing, and the example of Andromeda, 2.5 million light years away. So for 2.5 million years, there's an unbroken chain of photons going through the interstellar void until it eventually slams into your eyeball. And no one could have predicted that photon would have wound up in your eyeball. So I don't know. Maybe that's why we do it. Maybe we do it because we like being out in nature. Okay, all right. I'm going to talk about the Sea Star. I expect someone's going to want me to talk about the Sea Star, so here we go. So recently there's been this big trend toward what we call smart telescopes. So smart telescopes use EAA, electronically assisted astronomy, to deliver something that's kind of in between a visual telescope and an astrophotography rig. So EAA uses some techniques from astrophotography, but with less image processing and shorter exposures. So a smart telescope will have no eyepiece, and instead they display live images of deep sky objects to a screen, possibly just your phone. The one that's really blowing up the internet right now is the ZWO C-Star S50, which does not surprise me. I have a lot of ZWO products. They're a great company for astrophotography. And it costs $500 out of the box, and it's built around a 50 millimeter f5 apochromatic refractor and a 50 megapixel Sony IMX 462 sensor. So this is going to cut through light pollution like nobody's business, right? Because a camera lens or camera sensor is just more sensitive than your eyes. And what you can do is, you're taking these short exposures and then you're stacking them. And because they're short exposures, the sensor is not blown out by the light pollution. The price point I would say is impressive for an apochromat of any kind. And these things are super light, easy to carry, easy to set up, easy to tear down. I've seen people put them in a backpack. It's dead easy. And it's very simple point and click interface. The app is very intuitive, which I expect nothing less from ZWO. So some cons: you cannot use this telescope visually. You can't upgrade it. You can't change the magnification, because when you put a sensor and a telescope together, it just has a native magnification. That's it. It also is a relatively small sensor. If this was an astrophotography telescope, I would say, hey, you should change out that sensor for something more expensive. And because it does an alt-az mounting, you're basically limited to about 20 to 30 seconds of exposure time, which for a lot of the users, if you're in a big city, basically after like 30 seconds, you're going to lose, the sensor's going to blow out the light pollution anyway. So the reason I'm going to steer you away from this product right now is that it's really early in the development cycle of these smart telescopes. It's not really clear exactly who this product is for. Is this product for astrophotographers who want something easier that they can just set up and play around with, not actually post anything on Instagram, but just, be happy that they saw a deep sky object? Or is it for beginners? It's really not clear, and I think there's going to be a lot of progress in this market. And at the same time, you might lose that sense of awe and wonder that I was just talking about if you're just looking at your phone screen at a thing that the camera is taking a picture of automatically. And so some more tips. You're probably going to want to find a dark area like this observatory here where we are. And you should not try to observe through the window of your Manhattan apartment. That actually happened. I had somebody approach me at an event in New York City. We were showing the moon, and this person came up and said, I bought my partner this telescope, and we tried to look through the skylight in our apartment. We couldn't see anything. Yeah, duh. You're spending all this money for this finely polished glass and high-quality optics. You're going to point it at a dingy window? Of course it's not going to see anything. You want to allow about 30 to 60 minutes for your gear to cool down to ambient temperature. The telescope's going to provide the best views when the air inside the tube and the mirror are the same temperature as the outside air. And you want to allow about 30 to 60 minutes for your eyes to adjust. So you should not look at any bright lights. Yes, I know, including your phone. I know it's terrible. And when you're observing, and that's why you want that red flashlight or glow sticks to find your way around. The rising heat from buildings is also going to mess up your view, so try to look away from any nearby houses, not in a line that goes directly over your roof. And if you wear glasses, you might want to take them off and adjust the focus to your prescription, unless you have astigmatism. This trick doesn't work if you have astigmatism. And finally, you want to have a plan, or at least bring some field guide that you can work from. The Messier one is really good for that, because it actually has a little chart in the bottom right where it's like you pick what month it is, and it tells you what to start from, and then it'll tell you like what chart number to go to next, and you have the whole night basically of stuff to look at. Okay, so one more tip. This hobby can really fill up your car fast. This is what my old car, I sold this car, looked like when I was going up to a 5-night camping and astronomy convention in Vermont. So in this picture, you see 2 telescopes, a tent, an eyepiece case, a table, a pillow, a couple of chairs, and a spare tire. Spare tire didn't get used that much. All right, now I'm going to tell you not to buy a telescope. At least not yet. Take your time. You're already here at Jenny Jump Observatory. You can get to look through a lot of great telescopes here for free at these clouds. So spend some time looking through them to get an idea what you want. By the way, donations are accepted. Your local library might have a telescope loaner program, so you can check out a telescope like a book. These are often the Orion Starblast 4.5. You should join your local astronomy club, and they might have a telescope loaner program. I've actually had a telescope on loan from my club for like 6 months now. You might want to get started with binoculars. I don't use binoculars.
He's scared of the late fee.
I don't use binoculars for the night sky, but so that's why I didn't spend a lot of time on them in the talk. But if you're looking at the prices I'm listing for even like the cheap telescopes, and you're like, oh man, I can't spend $250 on a telescope, then I would say buy a pair of binoculars. You can get a really good pair of binoculars for like $50, and any telescope you're gonna buy for $50 is gonna go straight in the trash. Look around for used telescopes. Telescopes are pretty sturdy, and you can often get a great deal. Astromart and Cloudy Nights are two really great places. Going on Cloudy Nights is like taking a step back in time, because it's basically like a BBS from the 90s. Has never been updated, and I swear the way we actually do this is astronomers like me, we post stuff on Cloudy Nights. Somebody says, I want it. That we PayPal each other the money, and so far that money, apparently, like, no one is scamming anyone on Cloudy Nights. It's not like Facebook Marketplace where somebody says, hey, I'll send you a pair of headlights for your truck for $900. Just send it to me. Don't ask me about how this whether that happened. So your local astronomy club probably has somebody trying to offload some excess gear as well. If you're in a club, you get the emails. People always have something to sell. And you may find that even with a lot of telescopes and equipment, your favorite part of astronomy is still just that time you spend in the great outdoors under a clear night sky looking up with your naked eye. And now, finally, one last time, say it with me. The best telescope is the one that gets used.
All right. Thank you, Dan, for another wonderful talk. So we are going to be doing a Q&A session. But before that, I saw a couple of you sneak in after I had done the safety briefing, and the safety briefing is unescapable. With that, if you need to use the restroom, that is the porta potty in the back to my left, your right. It is illuminated by red, because otherwise wandering around in the dark looking for the toilet is annoying. We also have a museum and gift shop area that I will be manning after we get through the questions and answer sessions. When we leave here, using headlights, no one getting run over, okay? That being said, any flashlights or cell phone lights we're using to wander around in the dark, do point them towards the ground, because we don't need the rave lights blinding people. We had that a couple nights ago where I think someone was like, woo! It was rather annoying. Let's not do that. So, for the people here, how it's going to work, you're going to raise your hand in the air and wave it around a bit and keep it up when you have a question, when I call for a question, because I'm kind of like a T-Rex in the dark, especially since right now I have like no vision out of my left eye. So assume if you are not moving, I am the T-Rex in Jurassic Park and I cannot see you. For the people online, you get it easy. You just get to type in the chat and I have you on my wrist. So, with that, we'll start out with the first online question. Do you think that at one point astrology had merits?
Okay, that's an interesting question. So what I will say is that, so first of all, we have the names mixed up, right? Astrology means study of the stars, and astronomy means laws of the stars. So actually, they should be the other way around. What we do should be called astrology, and what they do should be called astronomy. But it's too late. So astrology and astronomy began as the same thing. They were one and the same. It was just the process of going outside and trying to figure out what's going on in the sky. And particularly, astronomers and astrologers in the ancient world were basically like calendar guys. Like, it was just like, hey, we need you to figure out like when it's time to plant. So in a certain sense, I feel like it did have merit in that, like, a lot of our ancestors relied on the night sky just to tell the time. So for instance, like in ancient Egypt, they used their signal for planting was what we call the heliacal rising of Sirius. So heliacal rising is like when it's like the last sunrise where you don't see the star right before sunrise. So the first time they would see Sirius, they'd be like, "All right, it's time to plant." So I think in that sense, astrology has some merit, and obviously, it's a piece of our cultural heritage, whether or not we believe that it's true. So in the sense that like all kinds of beliefs of that type have merit, I would say it has merit or had merit.
All right. Was there a question out here? I see. Oh,
Hi, Mike.
Question. Would you recommend a certain type or a certain telescope for specific objects? For example, let's say I wanted to look at planets. Let's say I wanted to look at galaxies.
So for galaxies, so here's the thing, right? Galaxies range in size from Andromeda, which is enormous, to like little teeny tiny ones that are basically the size of a star, right? Like if you want to see a galaxy, you probably want to see Andromeda because it's the easiest one to find. If you want to see the dimmest, most distant galaxies, you're going to need to spend a lot more money. I would generally say like if what you're interested in doing is looking at the moon and the planets, which are visually small but relatively bright close objects, then you're gonna want a high focal length. I've noticed that like this is sort of an alternative, and actually I have a bonus slide with this telescope. So this is a habit I got from academia of including bonus slides. So this is some pictures of my telescope collection. So this one, which made it to India, this is my mother-in-law, my sister-in-law looking through the telescope at Jupiter. So this is a 4-inch Maxitov. So this is a similar to an SCT, but it's going to give you the extra focal length. So if that's what you want to do, you can get one of these for like $350, and you can kind of use them like a refractor, but they have more focal length, and that's good for the moon and the planets, because you want more magnification and you don't necessarily care about the fact that the aperture is not that huge. If you're more interested in galaxies, I would say something like this 6-inch Dob that I have on my homemade base here, which has a a smaller focal length, and thus gives you a wider field view. I would say that's probably a better option. And this is my astrophotography rig, which is built around a 6-inch Newtonian.
and this is also why we suggest don't go out and buy a telescope right away.
Yeah.
Find your local astronomy club or one that has a variety of telescopes and look through them and decide, man, I really looking through all the objects in this one. Didn't so much enjoy that one, because that'll inform greatly your decision. And also ask about up and tear down times, because those are also important.
And weight. Dobsonian is basically like depending on how big it is and what the base is made of, you're gonna be talking about maybe two pieces that are each about 20 pounds or like maybe 30 pounds. And usually you carry them in two pieces. Where like for something like a bigger SCT, so you see I have my in this picture with my dearly departed little pup. I have an 8-inch SCT. That's the Celestron. That's got a big heavy thing at the top. And if you get a bigger SCT like the 9 1/4 or like one of the 11-inch ones, that's going to be really heavy.
All right. So our next online question: why did they use a logarithmic scale and not like a different type of scale?
Like a linear scale?
Well, yeah.
I have no idea. I mean, why is a Richter scale I think logarithmic is advantageous in the sense that it allows you to fit like more, like the full range into like a smaller numerical space. I think that's probably why the Richter scale is logarithmic.
I don't know. So that's a question to research. Another question. Perfect.
Hey, my question is, what's the coolest thing you have seen in naked eye and using a telescope?
Oh, that's a good. That's oh
Yeah,
man.
and if you have a
Yeah, can I have a coolest thing I photographed too?
that's what I want
Yeah.
about. If you have some photograph, please
So
show us.
so naked eye. I mean, so I've seen Andromeda with the naked eye, and you can actually see Andromeda with the naked eye from here if you know where to look. I've seen M13 with the naked eye. That was pretty cool. Um, I think honestly, I think the thing that I would say is the coolest that I've seen with the naked eye is there's a star cluster in Coma Berenices, which we went up to Vermont for the eclipse, and we got an Airbnb that had a hot tub, which is something I never knew that was the piece of astronomy equipment we all needed was a hot tub because it was really cold outside, but I could just sit out there in the hot water and just look up at the sky while my astrophotography rig was running. And
His
I
next investment is a hot tub and a waterproof cell phone
yeah.
to control his rig.
And I noticed the star cluster and I had to like look up what it was, and I thought that made it really cool. So then the coolest thing I've ever seen visually through a telescope, I would say probably was the Saturn Nebula, and I saw it. I was in Vermont. I was at this Stellafane, which is a convention up in Vermont, and I looked at so many objects that I ran out of Messier objects. So I busted out my Caldwell book, looking at the Caldwell catalog objects, and I found out about the Saturn Nebula. And it's crazy. It's a nebula that looks like Saturn, and it's so small. If you just were slewing through, it would look like a star, and you would think that it was a star. But then when you look at it, through your like if you hit it with enough magnification, you'll notice the two little
Ears.
yeah, of Saturn, and you're like, whoa, that's a nebula that looks like Saturn. And then the coolest thing I photographed, I gotta say, hands down, has to be the comet Pons Brooks. So I was here when Pons Brooks was coming through. It's currently on its way out of the solar system, but I was here a few months ago.
Dan.
Yeah?
So I just saw a lightning flash.
Oh, do we want to evacuate?
So what we're gonna do is we're all going to have you calmly proceed inside, or if you so desire, to your cars. Like I said, we do live stream this on Twitch and YouTube. I just don't believe in keeping people out under a structure of metal rods.
Yeah, that's probably a good idea.
So we're going to pause the question and answer for a minute, and get you guys inside, and then we can continue our question and answer session, okay? So people online, if you could just bear with us just a minute. It was. We have 5 minutes left in Q&A. It's not worth all that, kid.
Alright.
I just got told the radar says it was going around us far, but we can still continue doing this indoors and answer questions without the visual. So
You're back there.
we're just gonna stay in here.
Oh, okay.
We're not gonna set up because
We're just wrapping up anyway.
yeah. Yeah, I just don't want to have people standing under.
And this is more intimate.
So, our next online question. Have you ever considered streaming your astrophotography sessions on Twitch?
Is that a question from you?
That
Also,
is
wait, am I on?
You should be on.
Okay. I there's a guy that does that. Astro Canuck does that.
Yeah.
Yeah.
A couple people do it. I know one of the other Twitch one of our Twitch viewers, Misadventures in Astro, also live streams their astrophotography.
A lot of my astrophotography sessions I'm not alone, so I mean it could be like a little podcast, but yeah, I've never considered doing that. Maybe that's something I'll consider at some point. I don't know if I could make it entertaining continuously.
Right. Was there a question from any people here? Perfect.
Why are the red lights used? It's more of a. Why are they the?
Yeah. So I
Right.
mentioned that. Basically, if when any light is gonna alter your night vision. But the red end of the spectrum just tends to have the least impact on your eyes. So that's why we tend to try to use red light.
All right. So our next online question: have you seen any space vampires?
Not recently.
Is it because you are using a reflector with the mirrors?
I've photographed a little bit with a refractor, and so it never showed up in any of my images. Oh, one more thing. There was someone asked me the coolest things I've ever seen. Another thing that is pretty cool that I saw one time is I was photographing the Crab Nebula, and I had a little dot moving through the frame. And you see that a lot. It's usually satellites. Sometimes you get aircraft. But what was weird was this one's had hang time. It was in this frame for like half an hour, and I was like, "What? How?" These usually satellites go right through, especially the Starlink ones. They go right through. And then it took me hours to find it, but I was able to identify it. It was Navstar 64, which is a GPS satellite. And you think, duh, obviously GPS satellite's gonna be up for a while because those things have to have hang time, right? Because you don't want your phone to like connect for 30 seconds and then move on. So I thought that was pretty cool, and I made a time lapse of it.
All right. Was there another question here?
Yeah, there's specific sites where you would recommend to buy your equipment from that are reputable, because there's a lot of non-reputable places out there.
Well, so I mentioned for used stuff, I think Cloudy Nights is the best. If you're looking for the like, I know the manufacturers will recommend dealers. High Point Scientific is good. I believe they're based here in New Jersey. They resell a lot of equipment, or they sell a lot of equipment from Celestron, Orion, and Skywatcher, and the other main manufacturers. Apart from that, I've actually bought some pretty good telescopes on Amazon. Although I would not recommend going to Amazon to buy a telescope if you don't know what telescope you want to buy, because a lot of telescopes on Amazon are trash. But if you're looking for a specific one, they'll often have the same price as you would get from any other dealer. And yeah, so I mentioned another one that I really like is Woodland Hills. They're based in California, but they ship all over the U.S. I bought that SCT I bought from them. Their website is telescopes.com, which I'm sure that's how they made a lot of sales over the years. Is they got the best URL.
You can buy on Amazon if you know what you're looking for, getting a name brand, Celestron, Mead, so on and so forth. If you just see a scrambled number of letters, and we've all seen this on various products where we look at like a watch and go, oh, here's Rolex, here's Timex, here's blah, blah, blah. Yeah, don't go with the random assortment of vowels and consonants.
Another thing I'll say that is really super duper important, and I want you to learn 3 things tonight. One is the best telescope is the one that gets used. One is that aperture is the most important measure for a telescope, and the third one I'll say is if a telescope advertises the magnification as the most interest, it's like, oh, it's 700x. That's a piece of trash. That's absolute trash, because you can make any magnification you want, if you just make the optical train sufficiently long, but that doesn't mean that it's going to look good. Like basically what you're going to have at every telescope is going to have a limit to, how much magnification you can put on before it looks like fuzz. And that's going to be true for a high-end telescope, a low-end telescope. And the mere fact that it can provide this magnification out of the box doesn't mean you're going to see anything at that magnification.
All right, so a question that I skipped online, and I didn't mean to. What advice would you give to someone who was perhaps gifted a telescope and has tried to use it and has become so frustrated they're ready to give up the hobby entirely?
Oh, that's when you want to join your local astronomy club. For a couple of reasons. One is that if you bring a telescope out here to Jenny Jump when we're open, or if you go to your local astronomy club's events, there's going to be somebody who knows how to use that telescope.
I mean, contact us on our social media, our Facebook. on our
And
Discord, a lot of us will try and get you the answers you need.
they can also tell you it's a piece of absolute trash that you shouldn't have bought. And then you can donate that telescope to the club, and then the club can sell the telescope and use that money for our daily operations. We accept telescope donations as well as financial donations. We sell them at trade shows, and according to certain people in this club, we can sell anything.
There is a buyer for everything, and sometimes there are people who can use or are doing interesting weird things who will use the not so great telescopes. We do not try and sell not so great telescopes to people who don't know what they're doing, because that's just mean, and we want people more interested, not give them hobby killers.
Yeah.
So, all right. So our next online question: what is a Vixen plate?
Oh, I should have.
You mentioned that
Yeah,
a couple
I
times.
mentioned it a
and
bunch
then
of times. Yeah. So Vixen is a telescope manufacturer from Japan. They're the thing that makes the Vixen plate interesting is just that it is a so the plate is the piece that connects to the mount. So with you're not allowed to call it a Vixen plate commercially because it's not made by Vixen, but they are Vixen compatible plates. So it's the closest thing we have to a standard mounting bracket. And basically, like if you buy, a telescope that has a Vixen plate, or you have the rings to attach to a Vixen plate, then you can mount it on basically any mount that you're going to buy. So you saw the slide where I have my astrophotography rig that's got a Vixen compatible plate on it, so I can put any telescope, even though you probably would not take an Orion Short Tube 80 and put a camera on it. Like, you're not going to take a $250 telescope and put a $1,500 camera on the back of it and put it on a $2,000 mount. You're probably not going to do that, but like you could if you wanted to use it with any rig, that any mount that has a Vixen compatible plate mounting.
that being said, you Franken mount your astrophotography however you want to Franken mount your astrophotography.
There was one night because I also shoot with a telephoto, and I didn't have a good like mount for it, and I happened to be here, and I put it on the EQ6, and everyone was like, "What the hell is this?" Because it's like a telephoto is really light, and EQ6 is designed for heavy equipment, and it looked really silly. But I was like, "Hey, I'm not gonna lose any frames to wind tonight because this thing is way over mounted."
Right. Another question here. Right. So our next online question, that there's some speculation that the views through the scope, I'm thinking that they're talking about the
The C star,
because it's at the end, aren't actually real time, but pictures pulled out of a library of sky images.
I mean,
Have
how
you
would
heard
how would you
anything
know, right? How would you know? It's proprietary software. I mean, I know they're using AI, and I mean, there's some debate about this because I remember like maybe about a year or two ago it came out that like Samsung phones have the super zoom you can photograph the moon with, and it uses AI, and so like people have been able to manage to get it to like trick it and like take a picture of like a white circle suspended like on a string, and it like AI interprets that as the moon, and it adds all the features. And so like people joke about this, they'll post like pictures from the Apollo missions. They're like, this is a good picture I got with my Samsung phone, right? And I mean, I think there's some matter of debate because I don't use a lot of AI assistants to process my photos, and maybe that's why they don't look as good as some other people's. Like a lot of the products that people are using to process their astrophotos use AI, either for noise reduction or sharpening. And I think there's some debate within the hobby of at what point are you like, why don't you just Google the picture, right? Like, and I don't know. I don't know what ZWO is doing there, but I think I think that ZWO is a good company. I think that like I don't think of them as a low cost manufacturer for anything, and I think that the products I've used from them for astrophotography are really good. I have ZWO cameras, I have a ZWO control computer, and people love their mounts, as you will learn if you watch last week's talk by Jamie, where he waxed poetic about how much he loves his ZWO AM5.
Also, that is something to keep in mind. Um, when you are looking at buying your first telescope, you should have done some research and, oh, I like this, and give yourself room to grow. You don't want to buy a telescope and go, oh, I've reached the limit. Now I need to buy another telescope.
I'm telling you, you're not going to buy one telescope. If you're really into this hobby, you're not going to buy one. You saw my pictures. I have so
But
many
get
telescopes.
one you can upgrade for a bit before you have to
Yeah.
upgrade the piece of equipment you just purchased.
This is one of the reasons I like steering people towards the Dobbs, because I find that while I have much more expensive telescopes to use, my favorite one is that 6-inch Dobb, because it sets up easy, it tears down easy, it can show me a lot of objects, basically anything I want to look at, and it's just fun to manually slew it through the sky. So, like, for instance, I talked about on the slide with the Messier map, I talked about the Virgo galaxy cluster. So, like, you get out in a dark sky with a Dobb, you can just slew right through those galaxies, pop, 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 and it's a lot of fun. And another one like that is in the winter sky, we have a constellation called Auriga. It's got a ton of cool stuff in it. It's got nebulas I photographed, but it's got these 3 star clusters, M35, 37, and 38. M36, 37, 38. M35 is off to the side a little bit, and you can just slew between them and just go pop, pop, pop. It's a lot of fun.
Oh, we got a question just right before that. People on online chat, if you want to get any questions answered, now's the time to get them in chat, because I am coming to the end of the online questions.
You've repeatedly asked or said to contact the local astronomy club. And is there a list of local astronomy clubs on your website?
There is. So our organization is made up of, I think we're 12 clubs now.
There are many much clubs. I have a map.
At peak, we had
Ooh.
14 clubs in the organization. And so we have links to all the local clubs in New
that
Jersey
are part
of our
of
organization.
Our organization.
In New Jersey, New York, and Pennsylvania.
That being said, there are more clubs than this. I know
Yeah.
for a fact, because I have been trying to reach out to them to get them to join us, so that we can, when people come up here to vacation in the state park, do their camping, we can then direct them back home. Hey, here's your local, South Jersey club. Here's your local upstate New York club. Here's your Sussex County club. So we do have that information online. For those who are online joining us from like Florida or Texas, I can't help you about your local clubs, but Google Maps is honestly really helpful. We do most astronomy clubs I know do try and post themselves on the Google Maps, or check out your library. Your librarians have a lot of information about what's going on in their local towns, and it's often a great meeting place. One of our newest clubs, East Brunswick Astronomy Club, actually uses the East Brunswick Library as like a home base right now. So libraries are also a great source to check out for where you might find us. We're usually in the dark, so sometimes we're hard to find.
We had a question here.
Have you ever tried spotting a black hole?
Oh, that's tough because you can't see black holes. But so you're never gonna see the only way we've been able to photograph black holes is with the Event Horizon Telescope, which is a collaboration of telescopes. Basically, it's an interferometry project that basically makes a telescope the size of the Earth from observatories all around the world, and that's how we were able to photograph the black hole in M87, which is a galaxy.
And I believe they were also using radio telescope data that was put through software to make it visual data.
That sounds right. So there is a black hole that's most closer to us. It's called Cygnus X1. So it's called Cygnus X1 because it's an X-ray source. It's in the constellation Cygnus. X-ray doesn't penetrate the atmosphere very well, so the way we found it was with sounding rockets, so like rockets that go above the atmosphere, is the brightest X-ray source in the sky. So every civilization in the Orion Spur of the Milky Way galaxy knows this black hole is there, and one of the guys, not me, but one of the guys in AAA actually recently photographed that region of Cygnus and was able to pick out in his photograph the bow shock caused by the black hole. So like when a ship goes through the ocean, like it creates like a
Wake.
a wake. There's basically that for the interstellar dust that the black hole is traveling through, which that blows my mind that a human being was able to do that from the ground. Under with not from space, but no, I've never myself seen a black hole. But I have been thinking about getting a tattoo of a black hole because it might help, specifically Cygnus X1, because it might help the aliens locate my home planet if they abduct me. Ask me about my tattoo later.
If they've abducted you, they already know where you live.
Well, yeah, but I mean, you ever like go out with some friends and then you wind up with another group and then like.
So you're just getting chain abducted along the galaxy, like
look, you never
human.
know what's gonna happen out there.
A human. Right. Another question.
Yeah, what are some great places with like low light pollution in New Jersey or New York?
Oh well, you're in one now. Yeah, this is a really good place. I mean so to me, I feel like the trade-off for Jenny Jump is like we have facilities. We have amenities that you're not going to have if you're in the middle of nowhere. Also, you may be surprised by this, but a lot of people find it really suspicious for people to be out at night doing like weird stuff. So like there's a lot of places where you want to get the police called on you. So if you look at this map here we have on the wall, this shows the light pollution in New Jersey. You will notice we're in this yellow zone here. Another point that I will point out to you is High Point State Park. So there's a campground up there. It's a relatively dark area. Down in South Jersey, this is the Belle Plains State Forest, the Wharton State Forest. This is where the South Jersey Star Party happens, is in Belle Plaine. So those are probably the two darkest parts of New Jersey. Basically this area up in like Warren County and Sussex County that's yellow, and then that area down in the Pine Barrens. Another area that is really good and relatively local is if you go up to the Catskills. I know a lot of guys from my club go up to the Assoacan Reservoir to do photography and visual astronomy. We also go up to this campground called North-South Lake for dark sky observing with the club. And the trade-off is different, right? Because like here, if you even see on the map, we have a lot of light pollution to our east from New York City and to our south from Philadelphia. So if you're looking north, you have a really pristine sky from here. In North-South Lake, it's more like north and south. You get like Albany, Poughkeepsie, like whatever. And then I honestly I really like going up to Vermont. I go for Stellafane. I've been to Vermont separately. It's like the whole state is Bortle 4 or better, which is about what we're at here. Most of Vermont is darker than that. There's lots of campgrounds and places and things, but it's not the dark. It's the darkest place you're going to get to in the Northeast, outside of like deep in New England, is Cherry Springs, which I'm sure some people here have probably heard of. I would not recommend immediately driving to Cherry Springs with your telescope, though. I mean, you could have fun with that. It's up in Pennsylvania. It's like the part of Pennsylvania that is the northern center. It basically was never developed because like the land is not really arable there, and so it's relatively remote, and it is an astronomy park. So like you have a bunch of amenities for astronomers. It's like $15 a night to camp there, and there's 2 star parties a year that happen there.
Right. So one of our online viewers says, I think in response to when you were listing places to get astronomy gear, the store Skies Unlimited in Pottstown, Pennsylvania has closed. And he also wanted you to mention, how do you safely look at the sun?
Okay, so you need a solar filter.
On the correct end of the telescope?
Yes, you need a solar filter. Another thing I'll mention about this is that you don't want your telescope to look at the sun without a solar filter at all, even if your eyes aren't on it, because if you're like a little bit off axis, then you can melt the optics on the inside of the scope. And this is before you even worrying about your own eye health, right? So like all my telescopes at the end of the night, I send them to point north because that's the one place where the sun can't be in the northern hemisphere, and so that way, even if I'm not there to put the cap on, then I can be sure that it's not gonna shine through. But you want a solar a solar filter for your telescope. If you want to use eclipse glasses, those are great. Make sure they are real eclipse glasses and they have the ISO certification on them.
And even
Don't
if
look.
they
don't-
are, if they do say check on your indoor lights, if you can see indoors with them, they are not
They're
good.
not solar glasses. Don't look through a CD. Don't try any of those old wives' tale things. If you're looking at an eclipse, you can look at an eclipse through like a colander or some kind of thing, as long as you're looking away from the sun. Like if you're looking at the shadow it casts, then okay. But if you're looking at the sun through some old piece of like paper or whatever, or like wax paper, you could damage your eyes, and you really don't want that to happen.
Yeah, we had actually done a program right before the April 8th solar eclipse where I went over some safety tips for that. You always want your solar filter on the light collecting end of your telescope or camera or whatever it is, which is the part your eye is not against, because that is where you need the filtering. If you put it before, I think I actually shared pictures of it during that presentation of what happens when you don't. You burn through your filter and then you have no more eyeballs. You have given your eyeballs the end under a magnifying glass treatment, and that is just no good. Don't do that. Which is also why we say don't, even if you're not putting your eye there, don't point your telescope at the sun, because oddly enough, it turns the sun into an even deadlier laser by focused light. And he also mentions Adirondack Park in New York is as good, if not better, than Cherry Springs in PA.
That sounds right. I've never been up to the Adirondacks, but on the maps it looks really dark. And there's another astronomy thing up there called the Adirondack Astronomy Retreat, and it's around the same week as Stellafane. So some people do is they go to Adirondack for the first half, and then they go to Stellafane for the second half of the week. If you want to spend a whole week just doing astronomy in the Northeast, you can do that. But it is pricier because it's like you're renting a cabin as opposed to camping.
All right. Were there any other last minute questions? All right.
So to become
So
a
we
member,
can actually cover that for here after the talk. Were there any other questions about the talk or whatnot? All right. So I want to thank you all for coming out. Thank you all online chatters for joining us. Sorry about the weather. None of our telescopes are open because we just have a front moving through, which is why we moved you indoors, just in case. So we do want to thank you all. Do check us out on our website, uacnj.org. It's where you're going to find a list of, like we said, our local astronomy clubs, as well as our upcoming and past talks. And do reach us out to us with any questions on our social media, our Facebook, our Instagram, as well as our Discord channel. And for people online, hit those like and subscribe buttons on Twitch and YouTube. It's completely free for those actions to follow us and lets us know we're doing a good job. With that, thank you all. Clearer skies than we're having right now, and good seeing.